Hello fellow Scratchers, I'm Griffpatch and I hope you're enjoying this 3D Raycaster series as much as me. In part 3 we managed to bring a non-player entity, Nano, into our game. So cool, and that was a big achievement, but we were left with the problem that we could still see Nano through the level walls. So we have our mission for today. We'll be covering pen stamping, drawing to and from lists, and creating a depth sorted list. Oh my word! Finally though, we'll fill our world with cloned entities to make things a lot more fun. Woohoo! So save a fresh copy of your episode 3 scripts and let's get scratching. This is episode 4. The problem we are facing is that Nano, as a Scratch sprite, will never appear behind a wall drawn using the pen. They just can't. The pen layer is permanently sat behind all sprites, and that's the way it is. The only way to overcome this is to use the pen stamp block, stamping a copy of our sprite onto the pen layer. Now, we can move the original sprite away and the stamped layer remains. What's more, we can now continue to draw more pen over the top of the stamped sprite, and voila! That is how we achieve the result we are after. Our next problem is working out when to stamp Nano, as some walls appear behind them, and others are in front of them. At present, we draw the entire Raycast scene in one go, and Nano appears pasted on the top. So, we will have to split up the Raycasting to draw the further away walls first, then Nano, and then anything closer to the player last. But to Raycast and draw later on requires us to store the results of the Raycast in some way, and that means using Scratch lists. We'll need to store each ray's X position, distance to the wall, and the wall colour. Right then, that's where we will begin. Click into the player sprite and find our define initialize Raycaster script. This runs before each Raycast. Now we make the 3 new lists. Draw X to store the X positions for all sprites. Draw dist to store the distances, again for all sprites. And lastly, draw type. Now I'm using this to mean wall colour, and it's again for all sprites. We want to begin each Raycasting sweep with our lists empty. So delete all of draw dist, type, and draw X. Excellent, a fresh start. Click into the Raycaster sprite. Okay now, what's the plan here? Rather than directly painting the level as we Raycast, we want to instead record all the information gathered from our Raycasting such that we can draw the scene later on. As such, we'll move all the pen drawing scripts out of this sprite and into the aptly named pen sprite down here for later. Therefore, under the When I Receive Raycast, separate off these 3 green pen blocks. These are for setting up the pen ready to draw. Drag them into the pen sprite, and then delete them from this sprite altogether. Let's just check they made it in there, shall we? Yeah, here they are in the pen sprite. Great. So click back into the Raycaster sprite again. Next up is the Define Raycast custom block. Nope, this doesn't draw anything with the pen, so we can move on to the Define Single Ray script up here. The first part is the Raycasting. We need to keep that the same, but aha! Now we are into the pen drawing. Separate these scripts off, starting at the if touching level colour block. The only exception is these 2 set distance blocks. They should remain with the Raycasting scripts. There, did you get that? Right, we are ready to start pushing values into the lists. We could just add them right in, but to make things easier going forward, we'll make a new custom block specifically for this job. Name it Draw, with a numeric input of type, then a label at X, and a matching input variable, X. Then pop in the label dist for distance, and a matching numeric input, dist. Now please be double sure to tick the run without screen refresh here. Otherwise you'll get bugs later on as we change things up a bit. So we make use of the block right away. But what data do we pass into it? Well, the X is easy, that's the variable X. The distance, yes, we have that too, it's this distance variable. But the type, that was to be the wall colour, right? So that comes from this if-else block here. The first colour was 58, so let's fill that out. But we still need this if condition. So how about we just drop the draw block in there in place of the set pen color. Then we can duplicate the draw block into the else and enter the second color number. That's 53 for me, like that. And again, remove the actual set pen color block. Excellent, that will do the job. Right, we are almost there. So, although we called this custom block draw, what it is really doing is saying this is where we want to draw, and instead stuffs the values into our list for later. So, under the define draw script, we need 3 add to list blocks. And we'll add each of these 3 input variables to the 3 lists. Just make sure to add the type input to the draw type list, the x to the draw x list, and the dist input variable to the draw dist list. Cool! That should cause our list to be filled up nicely. We can take the remaining pen drawing script over to the right, and then drop it safely into the pen sprite along with the other pen scripts. Then as before, we can discard these ones from here. Hooray! Click into the pen sprite. First job is to tidy things up. Bring the copied scripts into some free space. That's better. Now usually, while we code, I like to stop regularly so that we can test some things are working as expected. The best we can do at this point is to make our 3 new lists visible on the stage, tick those boxes, and then run the project. Now this is interesting. See how the lists appear empty? You'd be forgiven for thinking that we'd messed something up, but hit the stop button. And aha! Now the lists are suddenly full of data. What gives? All I can say is, don't worry about it right now. It's just to do with the order Scratch is running our scripts, and it won't cause us any major issues. Well, since the data is now visible, what can we make from it? Each list has the same number of items. That's good, as we are adding data to each one for each scan line to be drawn. I can see the X list appears to be filled with X positions, ordered from -240 to 240, as expected. That's a good sign. The draw distances look to be all set, and the type column is showing the correct 2 color codes that I added. Perfect. So we can move on, just hide the lists again. Right, to draw the scene, we need to work through our lists a row at a time, but we need to draw quickly, so let's make a custom block. Call it draw, and tick the run without screen refresh. And here we go. Drop the draw block at the end of the when I receive paint block. First, we must reset the pen canvas ready for our drawing, and we have the array scripts here, so bring them in. The other script is for painting a scan line of the level, but first we want to loop through the lists. A repeat block will do as well, but how many times do we repeat? Well, that depends on how many items there are in the list, so a length of list block, and well, the draw X list is as good as any. As we loop around, we need to keep track of which item or row number in the list we are up to. Make a new variable naming it row, and then the hash is a shorthand for the word number, so this is row number. We'll begin at row 1, so set row hash to 1. Then within the loop, we'll change row hash by 1 to take us through each item in the list in order from first to last. Okay then, awesome. Now we must draw a scanline of the level. Make another new custom block, naming it draw row. Run without screen refresh. It's a great idea to break code up into these custom blocks so that we can name things. Not only does this make it easier to know what a script is meant to do, but it also makes it easier to find the right script later on. Pop it in as the first block in our repeat loop, before we change to row 2, 3, and 4, etc. Right, exciting. Now we get to code the drawing scripts. Define draw row then. Our aim is to be able to use the painting scripts here, but they require an X variable and a height variable, and neither of these are yet set in this script. No, at present these values are still in our lists. But before even that, we don't have a type variable at all. Making a new variable, type, for this sprite only. And set type to get an item of our list, we use the item of list block, and choose the draw type list. We just need to say which item we want, and that of course we get from the row hash variable. This way, each time we draw a row, we will get the values from the next item in the list. The x and height variables are already created for us, so we can duplicate the set block and switch it to be set x. Just ensure to switch over the list to match the variable, so that should now be draw x. Just one more then, for the draw dist list, and the matching variable distance. Very good. Can we plug the painting scripts in? Oh boy, yes! Drag them together, getting excited, and now we can run the project. And hallelujah, we have success! We should be seeing the level drawing once more. That sure is a relief.
This is a public announcement. Griffpatch has noted during editing that he forgot to set the pen colour from the lists, and as such, we have temporarily lost the wall colouring. Many apologies for this. It will be rectified before the end of the video. Perhaps it was because he got distracted by...
Oh, wowzers! Nano is going haywire, though. They are certainly not ending up in the intended position from the last episode. That's okay, though. It's super easy to fix. Scroll up to the When I Receive Paint, and just drag the draw block up to the top of the stack. That then allows Nano to be positioned after we paint the 3D scene, leaving Nano positioned correctly afterwards once more. There, Nano restored. But gosh, what has this actually achieved? Remember the goal, to find out which walls are behind and in front of Nano. Okay, so take a look at this. Here is our scene as we have it now. I've taken the liberty of drawing an oval shadow under Nano so that we can easily see where his feet touch the ground. Now it's pretty obvious that this left wall should be drawn in front of Nano. So let's watch this scene draw in the order that Scratch is drawing it. Essentially, we are drawing from left to right, the same order we are raycasting, and then Nano is popped on top. Bad. They need to be drawn behind the wall. So we might try drawing again until we reach Nano, stamp them, and then continue to draw the level? Well, no, that doesn't help either, because the next walls should have been painted behind Nano. Now they are in front. No good. So what we need to do instead is paint everything behind Nano first, then paint Nano, and then paint the remaining scene in front of them. That will guarantee everything is drawn in the correct order. And order is the answer to how this needs to be done. We must take the data we add to our lists and sort it, ordering it by ray distance, the distance to the wall. The items at the top of the list should be the furthest away, so they draw first, and the items at the bottom of our lists being the closest walls, and so they draw last. That is perhaps a bit of a scary thought. Ordering a list in Scratch? Oh, but fear not, it's not so bad if we take it a step at a time. Since our lists start empty, we will assume the list is always in order. Then each time we want to add to the list, instead of adding to the end like before, we find the right position in the list to insert the new row that will keep the list in order. This we repeat over and over until we are done, and the list is guaranteed to be and stay fully ordered. This is called Insertion Sort. So let's begin. Click with me into the player sprite and find the Define Initialize Raycaster script. I'm going to begin by adding a dummy value to our empty raycasting lists, and add to our draw distance list the value 999999. Wow, this represents a distance that is far, far away, much further than any wall will ever actually draw. This little trick will help simplify our scripts as it guarantees an upper limit is already in place. Now add a blank item to the other two lists, the draw type list and the draw X list, to keep things balanced. Sweet. Next we make a new variable, naming it draw index, or draw IDX for short, for all sprites. We will use this to keep track of the position in the list we are inserting into, but rather than starting at 1, set draw IDX to 2. We never want to insert anything in place of item 1, the dummy boundary row. Cool, and now the real fun begins. Click into the Raycaster sprite. And yeah, we need to update the define draw script. Previously, we were always adding new items to the end of the list. But now, to keep the list ordered, we need to search up and down the draw distance list to find where the new distance should be inserted. We begin by looking above the current item. If it is closer than our new distance, then we move up the list. So repeat until greater than item of draw distance draw index subtract 1. That's the item above us in the list. And compare it to dist input variable. Then in the repeat loop, we change draw index by -1. Okay, what? So we are repeatedly moving up the list a row at a time until we find a row above us that is further away than the distance we are trying to insert. Cool, but what if our new distance was already closer, not further away? Then we would need to search down the list instead. So repeat until, and this time use a less than operator. Item of draw distance, but another change, just use the draw index variable without the subtract 1, and compare to dist. And we change draw index by +1. Yeah, so we are repeatedly looking down the list until we find a draw distance closer to the player than the new distance. Great stuff, because at this point we have found where to insert the new slice of wall. We can't use the add to list block, we need to use 3 new insert item at blocks instead. These give us the control over where to insert into the list. Make sure to switch them to the draw type, draw X, and draw dist lists. Then move over the matching input variables. And finally, we say where we want to insert into, and that is the value of our draw index variable, 3 times over. Oh gosh, wow, that was some serious scripting. I hope you are all still following along okay. Do we dare give this project a test? Hopefully everything is still working. Oh yeah, cool, the level is still there. The question is, can we tell if it's drawing ordered from back to front? Luckily there is a quick test we can do. Stop the project, click into the pen sprite, and then single click on the Draw custom block. Now the stage will redraw slowly in the order the items are set out in our lists. And woohoo! Yes! That's certainly not from left to right, but instead drawing from back to front. That is so awesome to see, and well done you if you've managed to get this far. Now we are truly coding. So let's take stock. Our level is now drawing from back to front. Check. We have our nicely positioned entity, Nano. Check. Our entities are being correctly drawn behind walls. Bah! Fail. And of course not, for they are not part of our ordered list. To draw Nano in the correct layer, we need to shuffle them into this list too, keeping them all nicely in order, all together. Well, okay then. Click into the Raycasting sprite and we'll take our beautiful define draw script and copy it into the entity sprite. That's right, just drag it straight in. Then click into our entity sprite and move it into some free space, like so. We need to find the define rotate view script. Here it is up here, and drop in the awesome draw block. We are going to insert Nano into the list. Now, what type shall we assign to Nano? This is not going to be a colour, so perhaps we can use their costume number instead. Costume 1. As a side note, if you are using 1 as your wall colour, then go back and add 201 to that number, so 202, and that will fix this potential conflict. Now, the X position. The X position stored in here is the perspective adjusted X position. We need to therefore do the perspective correction on our VX variable before we add it to the list. Do you remember how to do this? Multiply the X position, that is VX, by dV divided by Vy. That's the distance. Cool, the last input is just the distance itself, and that was Vy. Brilliant. Oh, I have one little optimization we can make. When Vy is less than 0, the sprite is behind us. There's no point drawing or even sorting one that is behind us, so surround the draw block with an if and check that Vy is greater than 0. That is, it's in front of the camera. And on we go. Click into the pen sprite. Let's work out how to stamp this entity now that they are sorted into our draw list. So here is where we previously positioned the entity sprite. No longer. Just detach that script, leaving the single draw costume block to draw the 3D scene. Next, we use a hide block to ensure the actual nano sprite is hidden. This won't stop us from stamping copies of them onto the pen canvas though. Great, bring up the define draw row script. So coming in here, we now need to consider how to deal with a type of 1. It means we are drawing an entity with a costume of 1, not a wall as we would have previously been the case. We should split the script so that we can handle both scenarios. Detach the set pen block. We just need to save this set height block though, as this is needed for both walls and entities to adjust for perspective. Keep that, but the rest of the scripts are for drawing walls, so put them with the set pen here. And now we check the type. If less than, if type is less than, say 10, that will let us use costumes 1 to 9 for entities, which will do fine for now. Okay, time for a new custom block to handle the entity painting. Name it Stamp Entity. Run without screen refresh. Just attach that to the old entity scripts for starters, and we'll revisit that in a mo. We want to use the new block right away in our if condition, but we also need a stop this script afterwards to prevent the rest of the scripts from drawing a wall too. Now you may prefer to have used an if else, but I do have a habit of trying to avoid lots of scripts nested inside each other where possible, so out of habit, here we go. Right, let's look at the stamp entity script. Actually, there isn't much in here that we're going to need to keep. We've now already calculated both distance and height, so bin them. Set size 2. Oh yes, we need that. That's all good. Then we have the go to XY. And this is wrong. We can chuck the X maths blocks, and in its place we simply place the X variable. Remember how we already made the perspective adjustments before adding it to the list just now? So cool! And so finally, with the entity sized and positioned, we stamp. Marvellous, because that means, can you believe it, we can finally test this out, and I'm dead excited to see the entity finally integrated into our scene. And here we are. There's Nano, looking a bit more pixely than before, and that's no bad thing, as it fits nicely into the style of the pen-drawn level. And next, shuffling around the side of them to view them from behind a wall. Oh, here we go, and yes, guys, look, fantastic! Half of Nano has been obscured by this front wall. Amazing! Hey, I know, let's drag the 2D Nano entity around the level. This really shows things off. I can move them back and forth and behind the wall, and they are hidden perfectly. That is so cool, isn't it? And I should be able to bring them right in front of the same wall too. Yeah, there we go. And how about this wall? We can have them in front and take them all the way around the back. Hold on. To see things at their best, let's set all the ghost effects back to 100 to hide the player and the level sprites. And we'll also need to add a new set ghost effect to the entity sprite. Set ghost effect to 100. There. Oh yes, doesn't that look good? You know, I could play with this all day, but you'd soon get bored of me, so come on, let's keep going. One thing we haven't yet addressed is getting the entities to fade to black as they move off into the distance, to match our walls. For this, click into the pen sprite and find the stamp entity script. Now, we can't use the pen brightness block for this. We need to use the set effect block from the looks category. And we use set brightness to and drop it in before we stamp. This works a little differently to the pen brightness maths. A brightness of 0 means normal brightness, and negative numbers get darker. So we need a subtract operator. On the left, enter 40. And on the right, drop in a divide operator block. We can divide distance by 1.5. You can play with these values to find out the ones you like, but this value works good for me. Let's take a look. Oh wow, that's already really creepy. Is that you, Nano? Oh phew, yes, it's you. Very cool. That definitely integrates Nano into the scene far more naturally, and I love it. But Nano, he looks so lonely. Just him, alone in the shadows. Oh, how about we give him some company? This was never supposed to be about just a single entity after all. We should click into the Entities sprite. And here we are, setting up one single Nano entity. Well, if we want more, we'll do well to use clones, and to create them fast, we'll need a custom block. Name it Spawn, with a numeric input count, followed by a text label of, and finally another numeric input, type. Run without screen refresh. Use the block right away, and we'll spawn, that is clone, 25 entities of type 1. Costume 1 is the Nano costume in my project. Wow, this is going to be so cool. Drag the define block into some free space. First thing we'll do is show this sprite. We'll need this for the collision detection with the level. Don't forget that although we are drawing this in 3D, at the end of the day, they are also 2D scratch sprites in a 2D costume level, so collision detection is completely possible and useful, just like we have for our player sprite. Now create a variable, type, for this sprite only, and set type to the type input variable we just passed in. All of the resultant clones will then be set to this type, a 1 for Nano. Then we repeat to create each clone. The number of clones we want is given by the count input, and that was 25 nanos, right? Yeah! Next, we position the clones. I want this to be a random position around the map, so use a goTo random position block. But hold on, what if a Nano ends up randomly positioned on top of a wall of the level, or even starts on top of another Nano entity? We don't want either of these to occur, so repeat until not, then pop in an OR. The first thing to check is touching level. That's the easy one. So not touching level or touching another entity. But nope, Scratch won't let us choose entity in this touching block. Pants. Okay, fine. Let's work around that. Throw it away and click into another sprite. Bring in the touching block again and now select entities. Then we drop that back into the entity sprite. Right, click back into the entity sprite. Here's our touching entities block that we needed. Pop it ruefully into the OR block. Okay, until we are not touching the level or another entity, go to a different random position. And that will keep going around and around until the entity lands happily in some free space. Once there, just create a clone of myself. Make sure that's done outside of the inner repeat loop, but within the outer repeat count loop. Wow, we are nearly there, guys. At the bottom of the script, to keep things tidy, set type back to the empty value. And then hide this sprite. Oh man, this is it. Time to run the project. Ha ha ha! Look at that! A herd of wild nanos has appeared. What's so cool is that you can see they are layered correctly from back to front. If we hit the green flag again, they randomly spawn in different locations around the level. Let's have a wander around. Oh hello, another nano over there. I wonder where the rest are hiding. Yeah, they are everywhere. So fun. It is surprising how many of these little entities we can add without overly slowing down the game. Which is a good thing because we will surely have a lot of fun with these going forward. We are now drawing to a close on this episode, but before I go, I'm suddenly far too conscious that I broke the 2-wall colour system of our level, ever since we moved to using lists. We gotta fix that. So click into the pen sprite and find the define draw row script. What is missing is the set pen color block. We never brought that over from the Raycasting sprite, so drop a new one in before we set pen brightness. Set pen color to, and that is simply the type variable. Oh yeah, wow, there you go, so much better. I knew something was missing, but I just couldn't place what it was until now. The game looks far better with the wall colours restored. Wow, I am so pleased we made it to this point. I didn't intend to teach entity placement in this series at all. It was started just as a quick and crazy easy way of creating 3D levels in Scratch, but since you guys were so keen to keep on going, here we are now. And I have to tell you, there's still more to come. From here, it's not a big step to creating collectibles, level progression, different entities and enemies. We can look at how to make these enemies move around and chase us, and could even add projectiles. Wow, wouldn't that be something? Do fill the chat below with your comments. I'd love to hear how you're getting along. Don't forget to submit your project to the Scratch Studio linked under this video too. If you've enjoyed this tutorial, then please smash the like button and make sure to subscribe to the channel. Yep, subscribe now, there's no time to lose, and that way you won't miss the next exciting episode. If you feel you could support me more in making these videos, especially if you're an educator, then please consider joining the channel membership. A huge thank you to my channel members and a special shout out to Emperoros55, Code Nerd Scratch, Male 1835 and Sean Higgins for their tremendous support. Okay, that's it from me. Thanks for watching, have a great week ahead, and scratch on guys.